It's one thing to listen to doom and gloom about food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. It's quite another thing to hear practical, immediately actionable advice from experts who can help you reduce the fear, anxiety, and burden of these problems. Tune in now to the Surviving Hard Times podcast from the Finding Genius Foundation with Richard Jacobs. Hello, this is Richard Jacobs with the Surviving Hard Times podcast, sponsored by the Finding Genius Foundation.
I have Gary Conley. He's the chief scientist of a company called Second Nature. Second is spelled the number 2, N is in Nancy, D is in David, Second Nature. So we're going to talk about his work there and his expertise in hydrology, pollution dynamics, and applied math. Their goal appears to be to create decision tools to help cities in the U.S. tackle water pollution problems. So, Gary, thank you for coming. How you doing?
I'm great, Richard. Thanks so much for the invitation. Really happy to be talking with you today about the work we're doing at Second Nature, water pollution problems, and whatever else we get into.
So you mentioned water pollution problems. Does water pollution occur in places we think it does, or is it occurring all the time or intermittently with traditional drinking supplies that we rely on as safe?
Yeah, well, the answer to that is it is occurring all the time. There's, two main sources of the problems that we have, and that's growing our food and our cities, right? We apply fertilizers and pesticides, herbicides on farms to help grow our food. Some of that washes off into the streams, eventually gets its way into the ocean. Similarly, in cities, there's just all types of different compounds that make their way via runoff from the city streets into streams, eventually to the ocean. And there's just a number of impacts, right? They can create toxic conditions in these streams that are harmful to living organisms. They can find their way up the food chain back into the food that we eat, and it can pollute our drinking water supplies. So water pollution problems are just ubiquitous, and we need to find better solutions to deal with them, because up to now, we just have not made a whole lot of progress. Since the Clean Water Act in 1972 was enacted, we've done a lot of monitoring to identify the problems. We've gotten really good at finding out which areas are problematic, convincing demonstration, progress towards solutions. We're still on that road.
I live here in Austin. We've had a water boil notice, every year for the past 3 or 4 years now. Seems like things are getting worse here. What are you seeing in various municipalities and water supplies? You said there's a lot of monitoring, but is there still now more contamination than ever, or is it just noticed? What's the state of our water system in the U.S.?
Yeah, I think both those points you just said are relevant. Is there more, or have we just noticed more, right? And we can notice more if we're looking more, right? So there is some of that, right? The more monitoring that we do, the more likely we are to detect these problems. And I'm not mostly talking about direct contamination of drinking water supplies. I'm talking about what we call ambient water quality. So the streams that people may drink out of, but they provide beneficial uses to folks. So that's drinking, swimming, fishing. The mechanism by which we determine whether or not those are healthy for those activities is the monitoring. And if they get onto a list that the EPA administers, the Environmental Protection Agency, the water bodies on that list are not healthy for those activities. And we've got about 20,000 of those spread across the US. And every year we have some come off for some pollutants, but others go back on. So on the whole, we are monitoring more, but is also growing, right? And it's growing as we grow, right? Our cities are growing. The more they grow, the more we have to do to mitigate those impacts and the pollution that's generated from, a lot of it's from impervious surfaces, right? It just sort of runs off those surfaces, goes into the storm drain system, and gets out into the streams. So it's hard to say whether or not things are getting worse year by year, but it's certainly clear that there's only some isolated circumstances in which we can have real compelling evidence that they're actually getting better. And that's what Second Nature, our company, is largely involved with, trying to remove some of the technical barriers for identifying where those opportunities are to improve water pollution problems and tracking progress to see how close we are to those water quality improvement goals.
Well, what are the metrics? Like you said, no one seems to know if things are getting better or worse, but what are the metrics so we can tell what's happening?
That's a great question. And the ultimate evidence for whether things are getting better is what we can measure in the environment, right? We scoop a sample of water out of a stream or from a pipe, an outfall from a city, and we measure the level of contaminants, whether that's nutrients or bacteria, metals or organic compounds. We measure the levels in that water, and hopefully over time they're going down. It just turns out that's actually quite difficult to do. There's a lot of noise and other sources of variability in those samples. So we do have some examples of actually measuring improvements in those monitoring samples, and that's ultimately where we want to see that evidence. But we can only measure so many places and so many times, right? It's expensive. The water's flowing, everywhere. And so a lot of what we do to try to estimate how close we are to the goal is by using modeling and analytical tools to apply where we have measured, apply that information to greater effect across the landscape to estimate those places where we don't have measurements. And that's one way to estimate tracking of progress towards the goal.
What are you measuring? What are you estimating?
Generally, there's a few things we can estimate. One of the simplest is just, if for instance, if you're a city, are you reducing the runoff coming from your city, right? If you're reducing the actual runoff, it's say you've got features that allow that water to infiltrate and move more slowly towards a stream. Well, it's not going to be moving over the road and picking up contaminants with it. So generally, the more you reduce your urban runoff, the less problems you're going to have. Beyond that, we measure specific pollutants. So as I mentioned before, typical in urban systems, we have metals like zinc and copper that can create toxic conditions in streams, phosphorus, nitrogen, different bacterial indicators, and then various organic compounds. All these things are things that can create toxic conditions in streams and also eventually make their way into the food and water supply. So those are the things generally that we're measuring, and those are also the things that we can use various analytical or modeling approaches to try to estimate what we're doing on the landscape to try to mitigate those impacts is contributing to progress towards those goals. So if you're a stormwater manager and you're putting things in the ground, they're going to capture that stormwater and filter out those pollutants or just infiltrate the runoff so that there's less of that runoff. We can use estimates of how many of those there are, how large they are, where they're located on the landscape. And that's a way to get to a first level estimate of, how close you are to your water quality improvement goals.
What about water that goes to water treatment plants? Do you look at that to see what's coming out or no?
Yeah, we don't specifically at Second Nature work on that side of things. Another source, if you have overflow from treatment plants, so you have too much water going to them and you end up with these overflows, that's a little bit easier problem just because we know where it's coming from, right? It's overflowing that facility, and that's why you're getting an injection of pollutants into water bodies. The other problems I'm describing are more diffuse in the landscape. We don't actually know how much is coming from everywhere on the landscape. In terms of cities, so where the water would go to treatment plants, sort of gray water and black water from homes is some cities you have that mixed with the stormwater that flows through the streets. That's only about 700 something cities throughout the US have systems like that. We call them combined sewer systems. You've got about 10 times that more cities in the US that have a separate stormwater and sewer system. So 7,000 something. So it's definitely the larger source delivery of pollutants, those systems that have the water treatment plants separated out from the stormwater that goes directly from the storm drain system into water bodies.
When you say runoff from the city, where does the runoff go? What's defined as the boundary of the city?
It's a regulatory boundary. So the term we use is MS4. It's municipal separate sewer system. And there's a specific boundary for each city, or we say they're permittees. It's not just cities, other entities can have them as well. So it's usually pretty close to what you would see as the municipal boundary of a city. And that's just defined as that's the area that they are responsible for mitigating their water quality impacts. So a county obviously would have a much larger boundary than a city, but the short answer is they're just kind of regulatorily defined. Hopefully they also correspond with the hydrography or the landscape that dictates how the water is flowing. It makes it much easier to understand where the impacts are coming from. And
what if a city is polluting another city? What if its effluent is right near another city and it becomes part of its intake?
Yeah, that's a huge reason this is a difficult problem to solve, right? So if you have a big watershed and you have a series of cities, say going upstream, right? Say everything drains into a central river branch. Well, the water coming through that downstream city has already collected the pollutants that came from upstream. And so while those boundaries are separate, right, those boundaries that are regulatorily defined, that's a real problem that the hydrology doesn't follow those jurisdictional boundaries. So it presents a real challenge for, like I said, identifying who's responsible for what levels of pollution, because it all gets mixed together once you're downstream. And that's another one of those places where using analytics models and mapping can help us estimate the levels of impact coming from each of those cities and what their contributions to the solutions are.
So what are some projects that you're working on right now? Any specifics you can give?
Yeah, absolutely. Well, so, Second Nature is an environmental software company. So, we build tools to help cities and companies deal with these water pollution problems. And the basic idea is to try to put powerful tools that are based in science into the hands of people that are closest to the problem. So kind of the local stormwater managers, they are the best stewards of their cities. So we're kind of working to use technology to close the gap between kind of the academic level science and the policy making, right? Trying to make the science more actionable for the people who need to use it to make decisions on a daily basis. We try to stay pretty close to the science. So all of the elements that we have embedded in software that people are meant to use directly all have peer-reviewed journal publications so people can see exactly how the methods work. And this is just about making science more actionable for cities and companies working towards environmental sustainability goals, cities working towards satisfying the regulatory requirements. I sort of see it in the same way as, you used to use a specialized technician to set up your email server, right? But now the cloud handles that. The same is true for some of the analytical and modeling tools that we need to support environmental decision making. A lot of that can now be automated. And that's the bridge that we're really trying to create to make it easier for cities to use these tools to identify their priorities, track progress towards the solutions, and make the regulatory reporting more efficient.
So what do you do? What kind of capture devices and what kinds of things are you capturing from cities? And is it enough to become a raw input for somewhere else, or does that have to be disposed, or what is it?
So some of the data that we would use for that modeling that I described, well, a lot of that is just publicly available data from sources like the National Oceanic Atmosphere Administration. And so those data are sort of out there and available for anyone who wants to try to identify what those inputs to a model might be. But in terms of actual measurements, what we've done is set up devices right at the outlets to a city. So you just said a moment ago, like, well, gosh, it's really tricky if you have one city upstream from another city, if you're measuring in the main stem of that river. So to really understand what the impacts and improvements are from a specific city, it makes more sense to measure right at the pipe, right? We call them outfalls, where the water is going in to that main river stem. And so that's what we've done in some of the cities here on the central coast of California. We've installed devices on those pipes that can measure what the flow levels are as, say, a storm's happening and that flow level is rising in the pipe. And there's little inlets as the flow rises to take water samples automatically, so that you don't have to send someone out there to grab a water sample just at the right time. You have water samples taken automatically as the flow is going up, so that you know exactly what the water level is when you collect the sample. That's important for understanding the level of pollutant loading is. And so it just gives you a lot better information about the system, just having a little bit more innovative approach to collecting that sample, kind of pinning down the experimental design such that you're constraining a lot of the other variability that makes it difficult to detect the signal of an impact and a change.
Well, very good. Where can people go to find out more about the projects you're working on and see progress and what's happening with them in what cities, et cetera?
Yeah, you can go to secondnature.com. So that's 2ndnature.com, and you can see examples of the types of work we're doing, the tools that we're building, some of the science publications that we've done related to those tools, and some case studies, that will illustrate exactly what I described in terms of how those tools directly plug into those stormwater managers trying to actually find where they can get their biggest bang for the buck and how they can track progress towards their water quality goals. It's all there on the website.
And what do you think the future of your efforts is going to look like, in the next 5 or 10 years? Pretty much the same, or is there big changes coming to how stormwater is managed?
Yeah, I think it's going to continue going this same direction. Second Nature right now is a little bit ahead of the curve in terms of pushing the industry to digitize and go to the cloud and have heavier use of analytics for decision making. But it's hard to imagine it not continuing to go this same direction. So we're on the leading edge right now, but I'm positive the rest of the industry is coming this direction. And I think even more so as we end up with tools like Internet of Things, the sampling scheme that I just described. Well, you can also have that electronically connected to a system to tell you exactly when to take the sample. So the Internet of Things is going to play a huge role. Use of artificial intelligence to make identification of priorities more efficient, and just better use of models to identify what we should be doing where to make the greatest impact. Just continued progress in the same direction seems.
Okay. Gary, thank you for coming on the podcast and talking about your work. Again, best place to find out more is to go to where?
secondnature.com.
Okay. Very good. Gary, thank you so much for coming. I appreciate it.
Thank you, Richard.
Before you stop listening, ask yourself, what are 1 or 2 useful things you heard on this podcast that can help you overcome food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation? Please like and subscribe and tell your friends and family about their Surviving Hard Times podcast. We're all going to need help now and in the near future.